Over to you, so Paul.
Okay, well, good afternoon, everybody. I'm speaking to a computer here that I'm not sure is behaving itself. So my name is Paul O'Donnell. I'm an owner and director of a company called Unipipe Ireland, and we're the importers for the last coming up in 23 years now for NZEB Sweden, who are a very large manufacturer of heat pumps. I fitted my first heat pump around 1985. My next, this is where I'm getting one of the difficulties, my slides. Is that moved for you?
Yeah, it's moved.
What we do, what we are, a little bit about us. Okay, so we are in the heat pump business in a big way. We started off mostly, it was ground source heat pumps. Air to water heat pumps have taken over most of that business at this stage. We still sell ground source heat pumps for people who maybe have bigger houses or replacing older ground source heat pumps. And sometimes for reasons that wouldn't occur to you, such as maybe somebody wants to cool a house, believe it or not. So if you've made a very, very well insulated house and you need to cool it, you can cool it back down into the rock in the ground and store that heat that you didn't want and take it back later. So those are some reasons for ground source heat pumps. Air to water, of course, is a much more accessible technology for most people. There's no digging up of the garden, etc. So obviously for retrofits, that's much easier. And then we've a third kind of a heat pump. We sell a lot of exhaust air heat pumps, which we use in apartments and smaller, better insulated buildings, etc. So we, as I say, supply heat pumps. But we also service them, and that's a very important thing. I often wonder when people ask how much is a heat pump, etc. I often think they're asking the wrong question. It's, you know, what happens in 4 or 5 years' time. And we also sell backup products for the heat pump, such as ventilation, ducting, PV panels. And in solar panels, we have 3 kinds of solar panels. Most people are talking about PV panels. The solar thermal panels are the ones that just heat direct hot water, but we now have panels called PVT panels, which are liquid filled electric generating panels that are connected to a ground source heat pump. And then, of course, we have to instruct and show our customers how to use our products. So I've been asked here today, I think it was mainly to do with control of heat pumps. And of course, that is going to be a little bit different for every brand. So I'm not quite sure what my audience are today, whether they already have heat pumps or they're considering switching to them, but hopefully we'll pick up some tips today. Heat pumps in Ireland, you can just see that's just a graph. I won't linger on it too much, but there's been a huge growth, obviously, in the technology since when I first started playing around with heat pumps in 1985. It really was an outlying technology. And back then I hadn't heard of global warming, but what was obvious to me was oil back then was also expensive. And I just thought must be better ways of doing these things. And this has grown into quite a big business for us now. You'll see on this slide here, sales per country. Obviously in Europe, Ireland's not featuring very highly there. What struck me about this particular graph here is that you can see that it's from a couple of years back, but in Ireland, maybe there was 5,000 heat pumps went in. In Estonia, which is about the size of County Cork, 128,000 went in. Or Norway, with the same population, used 105,000 heat pumps. But in those countries, they've made it much easier for citizens to access grants. It's simply, in Norway, I believe, to just buy the heat pump and send the receipt in, they send you the grant. So in Ireland, we have to jump through a lot more hoops to get our grants. We have to have to ensure that the house is insulated to a certain degree, etc. So I think it's not a bad thing either, don't get me wrong, but I think we can get a little bit too tangled up in bureaucracy while we're at it as well. It gets a bit hard for some people. We get a lot of people giving out about this in our business. Plumbers who don't want to go back for training, etc. Trying to find a plumber who is both grant approved, and then finding another stumbling block is the very first step you have to go through, is finding an energy assessor who is enough time to get out to look at your house for you. So as I mentioned, three kinds of heat pumps: ground source, air source, and exhaust air. And why do people buy heat pumps? Well, of course, mostly to save money. So I just did this morning. It was interesting actually looking at it, and I have a funny feeling that the picture is a bit more fluid than this. This is SEAI produce a very good document. It's updated every 2 months, and the easiest way to find it is to simply Google domestic fuel cost comparison SEAI. You'll find the link on the page. So you can see that a year ago, a heat pump with a COP, that's a coefficient of operating performance of 4, on a mixture of night and day electricity was around 4 cents per kilowatt to run. The kilowatt's easy to picture. 1 bar of an electric fire like your granny had running for an hour, that's a kilowatt hour. The increases, of course, have come. So when we go on to the next slide, I updated it this morning from the latest available information. And people have often asked me over the last few weeks, oh, electricity has got more expensive. Is it still worth getting a heat pump? Well, of course, the answer is it's actually even more worth getting a heat pump because the gaps have grown up bigger again. You can see, for instance, that the order that I have the bars laid out in there used to be the order of increase of the fuels. I see wood pellets is now more expensive than natural gas. Gas oil has increased severely. LPG gas is up at 19.35 cents per kilowatt hour, burnt at 80% efficiency. And that would make it as expensive as running electric fires to heat your rooms instead of radiators a year ago. So I don't think that situation has frozen. I think it's going to keep changing, and that I'd say when we look again in 2 months, that but even by the time that the latest figures we have, of course, as it says on the chart there, October 22, but even in a few weeks things have changed. So I won't delay too much on how, when we're collecting heat from a ground source heat pump. By the way, it's usually one of these two ways, where we either bore holes into the earth to collect heat, which is what I did in my own house 20 something years ago. So that saved me about $2,000 a year for 20 years in my, I have to admit, non-heat pump ready house in SEAI parlance. It was built in 1971. It was insulated as best as I could practically do, but I don't think it would pass muster to get a grant. However, it works perfectly well. So many new houses in Ireland buried pipes horizontally in the earth to collect heat. So you'll hear people calling this geothermal heating, whereas none of the heat actually comes from geothermal sources. You'd have to drill down hundreds and hundreds of meters to get that. So typically a borehole is about 150 meters deep. You can collect heat from lakes, and a very infrequently used method is where we took water from one borehole and injected it back into another. They're called water-to-water heat pumps. These are some of the customer. I mean, these are the bigger end of the scale. Obviously, this guy had a castle in Cork, so you'll see the circular garden there has pipes buried in it, and that's what heats his castle. So, you know, you can see in this case, it's a bit of an extreme example, I'll admit, but, you know, he wouldn't want sort of air to water heat pumps hanging off the wall of his castle. Same with this house here, a nice new build house in Kiltiernan near me. Anywhere we walked around the house, he found it unacceptable to look at the machines. So we did 2 boreholes to heat the house. Bigger homes, like this was a stately home in Tipperary, but this was something like 35,000 square feet. Biggest house we did so far was 55,000 square feet in Limerick, I think. Nursing homes, that was the Laura Lynn's children's nursing home, combination of solar and heat pumps. So if we look at air to water heat pumps, biggest growth sector. I mean, most people find it's the easiest way to get compliance in building new houses is to use an air to water heat pump. So in most cases, they split into 2 types. You have ones that have warm water comes from the air to water heat pump, typically to an indoor unit. So in our case, these have always been a very nice looking unit from NZEB. It's a signature look. They have color screens on them. They're now touch screens like a smartphone. And in fact, our heat pumps now have got very smart. They're connected into weather forecasts. So when the heat pump sees warm weather coming the next day, it can turn down the heating during the night, because our attitude here is that you shouldn't really have to think about your heat pump at all. Not everybody likes the look of an outdoor air-to-water heat pump, and I see them sometimes being put in silly places, like in between bedroom windows at second-story level. That's really bad for the service guy in the future, and you should always try and keep these two pieces as close together as you possibly can. So what's new in air-to-water heat pumps? Well, we've kind of a long time gone away from things that look like homemade cylinders, etc. So the heat pumps are now pretty, and the indoor modules of the heat pumps can be fitted in the utility rooms, etc. Heat pumps originally were more on-off heat pumps. They just ran at full speed or off, on or off. Nowadays, almost all of our heat pumps can change speed with demand. And the gases that the heat pumps use, these are sealed bodies of gas for the heat pump process. The latest heat pumps we have now use actually propane inside them rather than refrigerant gases. And it gives us an advantage of being able to have very high flow temperatures, up to 75 degrees centigrade even. The units have become more compact, they're quieter. Big thing with the heat pumps is they're really starting to be integrated with other things in the home, such as the PVs or heat recovery ventilation systems. It all just comes back onto the same platform. So we have our new S series heat pumps, and these are the actual heat pump itself has got Wi-Fi modules built into it, so you can connect to Alexa, or with your phone you can use a product that comes with the heat pump called My Uplink. With Uplink, with your phone, PC, iPad, whatever, you can just touch any of the bars there to control what you want to do. So here you'll see examples in the second picture there. You can is what we call our smart screen. So when you walk up to any of our heat pumps, you can also get this smart guide, as we call it, and it depends on what's fitted in the building. If we have heat recovery ventilation linked into the heat pump, you can see it shows you here that you can just say, I want to boost my ventilation, or I want to change my hot water, etc. But this should have everything really worked out in the background by the machine. So inside an air-to-water heat pump, often people wonder, how do you just get heat from cold air? Well, there's no such thing in nature as cold. There's just heat out there. So even at minus 25 degrees air temperature, the NZEB heat pumps can, some of the models can produce 64 degrees centigrade from minus 25 degree air. And that's a very extreme example, but that's how they heat the ice hotel in Sweden. Our ordinary most popular sold units, they're called NZEB 2040 heat pumps. They have a very good annual SCOP, or seasonal coefficient of performance, of 4.4 to 1. And that's a pretty good deal. If you just are looking to work out how much is a heat pump going to cost you to run, you just take whatever you buy the electricity at and divide it by 4. That would give you the price per kilowatt, and you could look at that chart that I mentioned earlier, the domestic fuel cost comparison chart. So these are commonly placed, of course, at the rear of a property. I do see some of them fitted in front of houses and garage roofs and all sorts of places, but generally it's put around the back by the bins maybe. Trying to keep those two pieces close to each other is always a good idea. Long runs, even in super insulated pipes, etc. When the heat pump goes to rest, whatever's sitting in those pipes eventually cools off, and when you restart it again, that cold water is introduced back in, perhaps through the hot water cylinder coil, which will pull down the hot water temperature initially. Split units are ones where the refrigerant gas goes from the outdoor unit to the indoor unit. NZEB do make split units. We don't bother importing them. They tend to go more into housing estates, where the last €100 is the critical deciding factor for the builders. So as I say, we tend to concentrate on consumer driven heat pumps rather than developer driven heat pumps. PVs and heat pumps are obviously a match made in heaven. You're using electricity, your heat pump, your NZEB heat pump can actually talk to the PV system. So when there's enough electricity there, perhaps for the compressor to start, you can say, well, I've got free electricity. I might as well increase what's free and then multiply that free times 4.4, if you like. So that's a nice deal. Obstacles to upgrading, capital outlay, payback time, I suppose. Then we have a very generous grant from SEAI. But of course, every house is different. So we have to, somebody has to look at every single house, the installer skills and the supply chain, trying to find enough skilled installers to fit the products, because that's where we're part of the partnership and the whole supply chain, if you like. If we can't have guys fitting our stuff badly, then it will give us a bad name. So obviously we provide training to installers and we provide commissioning services to set up heat pumps. SEAI grant requirement, of course, is that you have 100% coverage of the needs of the house. That would say obviously take out larger properties around Ireland where they have a single phase electric supply only, which is a pity because actually I have to confess, in my own house, an oil boiler is still wired into my heat pump. And if it's very cold, I might use a little bit of oil. It takes me about 10 years to use 500 litres of oil, by the way. This is just a slide here of an old shop we did in our local village in Enniskerry. It's typical, it's in SEAI parlance, if you like, it's not heat pump ready. They didn't bother with the grant. They just put in one of our heat pumps, but they're very happy because if you go back to the price per kilowatt, it's still much cheaper to use a heat pump than if they wanted to use oil, etc. Exhaust air heat pumps are indoor units like the one on the slide here. We use these a lot in smaller homes, very well insulated homes, but also in blocks of apartments. And because there's no outside pieces, that means that we have a very ideal solution, obviously, for apartments, because you don't want to have air conditioning style units out in the balconies. They're much cheaper to use than if we had put in district heating for the whole block of apartments. That gives the headache of the owner of the block of apartments that they have to collect money from all the people for the heat, whereas at least with an exhaust air heat pump, it's just running on your electricity bill. Exhaust air heat pumps, again, have the controls are now upgraded to touch screens. We have units with higher outputs, so we now have a unit of up to 7 kilowatts. So we would put that in perhaps a new house up to 250 square meters. Bit of a bargain insofar as it does the ventilation as well as the heating and hot water. So sometimes when people are asking so much as your heat pump and they're comparing it with something else, remember, if you have to go off and buy heat recovery ventilation on top of the heat pump, it may have been substantially cheaper to consider an exhaust air heat pump. So most of the equipment is all inside these nice boxes that you're seeing, but we have many different ways of building systems, which is quite handy. And sometimes these technologies cross over with each other insofar as we can use some exhaust air heat pump technology with an air to water heat pump. So we can take waste air that was leaving a building and would normally have just been thrown out into the sky, if you like. We have a little unit that scoops 2 kilowatts of heat out of that and returns it back into the heating and hot water, used in association with an air to water heat pump. So with an exhaust air heat pump, we're drawing air in from bathrooms, wet rooms such as utility rooms in the kitchen. That air would normally, of course, be going in at 21 or 22 degrees into the machine. And it scoops a lot of energy out of that. It leaves the machine at -15. So we have to be very careful with the air leaving the building. And what we do is, notice the ducting has to be properly insulated. If it isn't like meticulously insulated, you have condensation, and anywhere where you left cold ducting exposed. And so an exhaust air heat pump sends its heat, just like the other two kinds, to radiators or underfloor heating. Jobs that we've done, such as Nazareth House, these would be typical for small sheltered homes around nursing homes. That each has its own individual little heat pump. Again, this is a very surprising place to put an exhaust air heat pump, but in my village, there's a 200-year-old an old courthouse building, and they've converted that into 3 apartments. So we put in dry fit floor heating and exhaust air heat pumps. So each apartment is completely separate. And even though it was a very, very old building, after substantially upgrading the insulation, etc., this was found to be the preferable solution. Again, here's an example of houses where we're ready to put an outdoor unit for an earth water heat pump, apartments, etc. These are ones we did in Barrow Street for Google. So on control of heat pumps and how you run your heat pump. So I see a lot of chatter on Facebook and things like that, people wondering what's a heating curve, etc. So a heating curve, I'm not sure if I can get this one up on screen here. That's just a little picture out of a book. You can see a red line there on the screen.
Sorry, Paul, we're not seeing.
You're not seeing that one, no?
No, unfortunately, we're still seeing the presentation.
Okay, okay, well, I can just talk you through it. So it's a much talked about subject, a heating curve. So if you get a graph and you plot the temperature that you need for a heating system versus the temperature outside, that line is slightly curved. So it's got this nickname, a curve or a curve slope or a curve coefficient. And all it means is that the manufacturers have preset curves for different houses. So if you were living in a passive house, you might be down at curve slope 2 or 3. If you're living in a kind of modern day Irish house, you typically see curve slope 5 or 6 selected. So this is just, you select a ratio of heat to the weather outside, and that's what the curve means. We've been brought up in Ireland addicted to the human running the heating system instead of the heating system running the heating system. So by that, I mean that if I ask anybody in Ireland how they run their heating, I usually end up with a speaking time clock in front of me, and they tell me I turn the heating on at 7, I turn it off at 10, it's on for half an hour at lunchtime, this kind of lark. If you ask somebody in Sweden or Germany or Switzerland or Austria how they run their heating, I think they'd look at you like you were stupid. They would kind of be confused. Why would they run the heat? It's like you don't run the fuel air mixture in your car driving along either. So it leads into a myth, though, where people say, oh, I don't like the idea of a heat pump. You have to leave them running 24/7. Of course, the heat pump is on 24/7, but it's not actually running 24/7. It clips in and out as necessary. So the curve slope, once you get that right, I usually urge our customers with thermostats to turn the thermostats up so that the thermostat isn't in the equation anymore. And if you get the level of heat correct on a curve slope, I would say it's a little bit like if we were to have Paddy Irishman and Paddy Swedishman in cars. Paddy Irishman has got his throttle stuck open, and in other words, he's controlling his car by just turning the ignition on and off, and the thermostats are the brakes. Whereas the Swedish guy just comes coasting up to the traffic lights without touching the brakes. So it's a little bit of an analogy somebody gave me once trying to understand this, and I think it was a good analogy. The traffic lights themselves then, of course, are like heating zones. So if you decide I'm turning off the back half of my house all day long, when the lights go green, Paddy Irishman goes roaring off at loads of power, and there's your oil boiler sends in a big gulch of heat into the radiators, and that zone heats up again quite quickly. But if you do that with a heat pump, it can be very slow to respond, because it's assuming the gentle heat heading to that part of the house that you had denied it access to all day long. It's assuming that it has been heated, so it takes a little while to catch up. So if you have a modern, well-insulated, airtight home, I think you should try this experiment. If you have a heat pump, find out what the heating curve is, and because otherwise it's akin to driving along in your car using too much throttle and dragging the brakes to control your speed in the traffic. Whereas you don't need to produce more heat than you need and then wait for the floor heating or the radiators to heat the air and then eventually tell a thermostat to stop and step back from that position. So finding the right heating curve is important. And that's a very personal thing. So for instance, my wife loves to be at 22 or 23 degrees all the time. And I suppose we play that same game, many Irish homeowners. The husband comes home and says it's boiling in here and she's too cold anyway. So even if you're back a degree, 1 degree or 1.5 degrees in your room temperature selection, that can be a difference of 7 or 10% in consumption. And so we have the scheduling of then your heating curve. If one assumes you've found the right curve for the house, obviously then you can go back down to the thermostats. I would see the thermostats with heat pump as being more useful for, say, operating at reduced temperature in bedrooms. For instance, you might set your bedrooms at 17 or 18, and the living areas can be left alone and kept at 21 or so degrees. Then you can set back these temperatures, of course, with any heat pump, I'm sure. But think about this: if the electricity is the very cheapest from 11 at night until 7 in the morning, is it worth turning the heat pump off for that period? So perhaps not. If we leave heat pumps running and don't touch them nor interfere with the controls in any way, they run roughly, any machines that we've monitored over the years, we'd see pretty much a 50-50 split of night and day rate electricity. So the little graph I had earlier there, where I got the 4-point-something cents per kilowatt for heat pumps, that was on a mixed diet of night and day rate electricity. But what you can do, you don't have to turn it off. You can always turn it back a little bit when you're not in the house. So setback temperatures, there's various control systems for that. Obviously, you can do it at the heat pump on a timer, probably on most makes of heat pumps. With ours, of course, you can do that with your telephone or with the PC, iPad, etc. And the other part of the equation I didn't mention was hot water. Hot water is usually done on most heat pumps on priority. In other words, it heats the hot water, or the heat pump runs hotter to do the hot water. When it's finished doing the hot water, it kind of says what's the air temperature outside, and it then produces the lower temperature usually required to heat the building rather than what it was doing the hot water. When warmer weather comes, our heat pumps then just simply switch off circulation to the underfloor heating or the radiators, and it just leaves during the summertime the hot water loads. Hot water with heat pumps, remember you can only take 38 degrees in your skin in a shower, so there's no real necessity to store very high temperature hot water in your house. In nursing homes and places like that, we have to demonstrate that once a day or once a week or whatever they ask for, that we get the hot water to over 60 degrees. It's called an anti-Legionella cycle. And the default setting in all the NZEB heat pumps is every 10 days at midnight they perform a Legionella cycle. However, the normal hot water temperature that we store for use in heat pumps, you could say, is around 50, 52, 53 degrees centigrade. If anybody wants to contact me directly, Paul at unipipe.ie. If you want to call in here and see things working, you're very welcome. We have a showroom and we're based in Bray, County Wicklow. If you just Google Unipipe, you'll find us. And if anybody has any questions, I can take them.
That's perfect. Thank you very much, Paul. It was really in-depth and some really good information there for people. We have a couple of questions here. I hope you could be able to ask right now.
Sure.
One from Revo saying, how long does it take on average to switch from a gas boiler to air to water heat pump retrofit building? I'm guessing that's probably without.
That's a real how long is a piece of string question, I'm afraid. But if everything, I suppose, if we had a house where it was easy to do, in other words, if you could, and we do get some houses I look at, and the gas boiler, the hot water cylinder is not buried off in the house with the wrong side. So some of the problems you'll get is, unfortunately, in Ireland, we have always spent as little as possible on our heating systems. We're not like Germans. Of course, it wasn't as cold here. So a typical shortcut I'd see in a house would be that you have the same circuit that's doing the radiators is feeding the hot water cylinder. And that, you know, in summertime, if you want to use your gas boiler to heat the hot water cylinder, you can lean over all the beds and turn off the radiators, since there isn't even a separate circuit. So little things like that can really hold things up. Whereas sometimes you walk into a house, there is already a separate circuit to a hot water cylinder. Most of the time, you would end up changing the hot water cylinder, by the way. Your ordinary little copper cylinder is not suitable for a heat pump. And if everything was, the conditions were right and we have the thing in stock, I'm assuming the customer here means how long does it take? We're including the grant. So at the moment, I'm seeing things like 6-week waiting list to get a technical assessor and the rest of it, just to go and start the grant process. So once he has given that the thumbs up and your plumber is ready to fit it, I mean, the actual fitting of the stuff sometimes can be as little as a day, but they could be 2 or 3 days doing it. There isn't a really one answer for all there, I'm afraid.
That's perfect. And the second part of that question is, do you take care of heating system design?
Yes.
Yes, okay. The next question then comes in from James, is like, what is dry fit? You mentioned it in your slides.
Oh, dry fit, it's nothing new, actually. We won an award for it in 2002 at Plan Expo. So it's almost like scale extric tracks, if you remember the old slot car racing game. They're boards of 20 millimeter high boards and also 30 millimeter high boards of insulation with aluminium on the top of them. And there's grooves pre-punched into or pressed into the aluminium. So you have hairpin bends and straights. So it's a little bit like the old slot car tracks. You cover your whole floor in it, you glue it onto the floor. The standard 16 millimeter Unipipe underfloor heating snap fits into that. And then your floor that you walk on is resting on it. So it's a great way of retrofitting underfloor heating into buildings. So my daughter's house nearby to where we are in Dean's Grange, which we would be happy to show to somebody if they wanted to see it. It was a 1963 house with suspended wooden floors and no insulation in the house whatsoever. There was old double glazed windows in it and she didn't have much money to spend. So I said to her before she moved into the house to give us a few weeks, and we lifted all the wooden floors downstairs in the house and we put rock wool insulation in between the suspended wooden floors. We put sheets of plywood back down on top of that insulation. And then on top of that again, both upstairs and downstairs, we fitted the dry fit floor heating. So she put laminate floors downstairs and carpets upstairs and ceramic tiles over it in her bathrooms. And she used one of our high efficiency air to water heat pumps. And I was delighted to see that all we did was dry line the interior walls with 50 millimeter dry lining. As I mentioned, the existing double glazing was there. And with the use of the dry fit, it meant that we didn't have to use concrete to retrofit underfloor heating. But she now has not just got floor heating, she's got floor cooling. So in summertime, she can cool the house at night if she wants by introducing cold water through those floors. And our house, I'm delighted to say, went from a G rating to an A3 with not so much spending.
Oh, that's amazing. That's some jump.
Yes.
There's
other benefits in it as well. It breaks the sound between the floors. So when my grandson is jumping up and down, running around upstairs, he's not so noisy.
That's a good additional bonus, you could say.
Yeah.
We're just running out of time, folks. I know there's a couple of questions in the chat. I'll send them over to you, Paul, and maybe you can probably get back to them in your own time.
That's no problem. Yeah.
I'll be sharing the slides today as well for anybody that's registered for the event, and also the recording will be up on the TUS YouTube page. Tomorrow we have Grant Engineering, who's another heat pump supplier in Ireland, and they'll be running through their product list and their heating control systems too. So special thanks to Paul for coming today. It was brilliant. Thanks very much, Paul, as always.
Thanks.
And thanks to everyone else that came as well. And I hope you have a good day.
Okay, and if anybody wants to follow up with questions, feel free to call. I see some of the ones in the chat here. Sorry, I should have opened that earlier. They're very quickly and easy answered. So
That's perfect. Yes, I'll circulate the chat to
Yeah.
Paul and emails as well. So that's perfect.
Okay.
Thanks everybody, and we'll see you again.
Thanks.